Hi everyone. So I will present our vision for future radio. Is it okay? Can everyone listen to me? Okay. So I will present our vision for future radio diagnostics using virtual reality. So physicians use digital images, and digital medical images are essential to diagnostics and surgical planning because they are easy to store and to share. Normally, radiologists analyze these images while seated in front of a screen. But if the radiology room does not meet the ideal requirements, there is a risk of diagnostic errors. Radiologists are fully aware of this, but as we all know, public hospitals and clinics may not have resources to build such an environment. So these are the factors that influence the study of medical images. Low quality displays, artificial and sunlight distort images and interfere with the reading of fine details. These rooms should be darkened and with multiple expensive grayscale high-resolution displays. Therefore, our goal is to cancel out these ambient factors using VR and provide a familiar user interface to promote the adoption by the medical professionals. And VR adds a lot of interaction challenges. So this is our approach, a virtual reading room that allows the radiologist to put aside the keyboard and mouse, focus on the medical data without the influence of those external factors, while using a desk surface to control medical volumes with natural gestures. Our contributions are a novel cost-effective approach, the establishment of VR as a tool to cancel out the factors that can cause diagnostic errors, and we also contribute with an easy-to-adopt interaction technique. We followed the scenario of a seated radiologist with a render of medical images in front of him, while using the desk surface to rest his hands and manipulate what he's seeing. And what he sees is the medical volume rendered from CT scans, and at the same time, he is able to see the proxy of the real desk, augmented with state and hand indicators. Instead of looking to menus, we employed bimanual interaction approach. Each hand is able to perform independent tasks. The left hand to change the render properties, and the right hand to manipulate the medical data. Also, resting hands on the table should not provoke an action. Therefore, with the left hand, the physician can change between each slice of the patient or adjust the image brightness. There is an indicator in the center that shows the specific body slice of the patient. In the back, there's also a brightness indicator. So with the right hand is then utilized for rotations and scale actions. There is a gesture to tilt rotate the volume, a pinch to zoom to change the scale, and hand rotations are used to change the anatomical plane. And finally, a double tap to reset. In regard to the implementation, we minimize the setup to the bare minimum to ensure the low cost and the portability of the setup. So we use the Oculus Rift DK2, and for now we use a commercial multi-touch frame attached to the table. We approach the touch detection to minimize undesired actions So we choose to cluster all finger touches, and we use that cluster to calculate the position displacement, scale, and rotation gestures. And the volume is rendered from the combination of multiple CT scans. So we performed a qualitative evaluation with medical professionals, with 15 minutes of free experimentation of a human pelvis with a fracture and a prosthesis. 6 medical professionals attended our evaluation trials, 2 of them radiologists, and all of them reported that they use this kind of medical images every day. The questionnaire was a set of multiple statements with a 6-point Likert scale. We also used observational notes and transcribed the interviews. So since this is a note, I will not bother you with tables full of numbers. I will jump to the results. So the results should suggest that the interaction design was adequate, useful, and easy to use, except for tilt rotation. Also, dental implantologists suggest that end rotations can be difficult for dentists, since they are prone to have carpal tunnel syndrome from the vibration of their instruments. In regard to data visualization, all participants identified the fracture and the prosthesis without being prompted to do so. All agreed that the resolution is insufficient for day-to-day diagnostics, and all agreed that this approach is a viable solution to deal with the ambient factors. Also, the general surgeon suggested that with sharper images and higher resolution, VR approaches could render invasive practices obsolete, like endoscopies. So, to conclude, we proposed an approach to deal with the ambient factors that can cause diagnostic errors, that combines virtual reality and tabletop gestures. Results show that our approach is appropriate. The user experience and the interaction technique are adequate, but the resolution is still insufficient. So this concludes my talk. I hope there's a little time for questions and comments. Thank you.
Hi, my name's Neil Davidson. I'm a children's doctor from Newcastle University. And thank you very much for a very interesting talk. I've got 2 questions for you. The first is, you had a lovely GIF at the front of somebody knocking over the pens. Yes. A radiologist, after they've reviewed the images, needs to type a report. Mm-hmm. Have you had any thoughts about how they would do that whilst also being able to look at the images?
Yes, the main vision, or the initial vision, is for the radiologist to be studying the images on a display, on a desk, and do their normal work, and just grab the HMD, put it on their heads, and see the fine details, manipulate, and then take those away and continue their work.
Brilliant. And you kind of answered my second question as well, which was, we often sit down as medical professionals with a radiologist and look at the images so they can talk us through it. Mm-hmm. Had you had any thoughts about how you might have multiple users viewing these images?
Yes, future work is definitely collaboration.
Brilliant. Thank you very much.
Thank you.
Hello, Lorenzo Wood from Publicist.sapient. A very interesting project.
Thank you.
I wonder, with the radiologists that you had as your subjects, did they comment on the need for this 3D visualization? And I ask that because of the resolution issue, because I wonder whether you could consider giving them, instead of since they're used to not having 3D, because that's what they do in their heads, they can use that bimanual interaction to enlarge the image dynamically and see those features perhaps rather than manipulate it in 3D. Did they comment on that at all?
The radiologists still, they do prefer to see each slice or each image in 2D. But they also stated that the depth perception, it's quite useful for navigation purposes. So to navigate in a column of a person, in the intestines.
Thank you.
And that's why they did not like the tilt rotation. They preferred to see a vertical image.
So do you have any questions? All right, so let's thank the speaker again.